Okay, it's 7 minutes and 20 seconds until we kick this off. Really looking forward to this. Got a great show for you tonight, and I just turned it down a little bit, so hopefully I'm not blowing your eardrums out anymore. Here we are at the 7-minute mark, getting ready for the second edition of Behind the Carvings. This one is going to be a CNC Q&A. So stick around, it's about to go live. We have had so many great questions come in about what kind of CNCs to use, what kind of bits to use, feeds and speeds, all kinds of additions. This is just going to be an amazing show. Welcome to start number 2. This time we'll do some audio. Welcome to episode number 2 of Behind the Carvings. This is a Q&A with focused on CNC. So I've been asking a few questions out there on the different social media platforms about things that people want to know. And so as we move forward, we're going to go through some of those questions. But please, as some of my live viewers, drop comments in the chat. Put a capital Q at the beginning of it so we know that it's a question, and we can search those out. And we will look at answering as many as we can. Hopefully we'll be able to get to all your questions today. If not, I am not above doing another episode where we're going to go in depth into more questions. Keep in mind, some of these questions are really deep questions, and we're going to be skimming the surface. If you want some more depth, please come back and let me know in the comments that you want to go deeper into this, and I can dedicate an entire either live episode or a video to that. So please light those comments up, and let's get into our questions. First question comes across is let's see here. I know we've got some questions somewhere. Okay. First questions came from Woodworker YouTubers Facebook channel and CNC for Beginners from AJ, Jaron, and Pamela. They all wanted to know what CNC to go for. This is probably the biggest question out there in the CNC world, and there are countless hundreds of hours of information dedicated to this. And the reason is because there is no one size fits all. There is no best machine. The thing that we're going to find about CNCs, and pretty much everywhere in woodworking in general, is it depends on what you need it for, what you want to do. If you're going to go into an industrial setting and you've got a full-blown shop, there's still 100 different machines you can choose from, but you're looking at a complete different category than if you're just a hobby user and you're going to use this in your basement. They are broken up into different size groups and price groups, and there's some really good entry-level machines in the $1,500 to $3,000 range, like your Shapokos and your x-carves. There's just so many machines out there. What it's more important to look at is, rather than which machine should I get based on somebody else's scenario, look what machine you should get based on your scenario. So you need to look at what capacity you need. So are you doing more turning pens and are just going to do a lot of little tiny work? Or are you cutting sheet goods to make cabinetry? There's a huge variance there, and once you figure that out, you can start looking at machines in your size range. Now we can start focusing on price, because price is going to be the great limiter. My advice to anybody would be go out and buy the best machine that you can buy to start with. But that's going to put people in a lot of bad situations. So as I started using CNC machines more, I've come up with a new answer. And that is, go and find a used machine. If this is your first CNC machine, go out and find something that someone has used for a year or two and they're upgrading. Or they haven't used nearly as much as they wanted to, or they got into it and the programming is too much. So for some reason, you don't want to get into something where, hey, I got this, I used it, I broke it, now I'm going to sell it to you for cheap. That's not the one you want. Find something that somebody can give you a demonstration on. You can see how it works. You can ask them a few questions. They can give you a little bit of a walkthrough, and something that you can use for a month or a couple of weeks and get familiar with. The last thing that I want to see anybody go through is say, you know what, I saw this really cool thing on the internet that somebody made, and so I went and bought this amazing $18,000 CNC machine that's got all the bells and whistles, and they get it here 3-4 months later, because there's a complete lag on machines right now due to shortages in everything. And then they try and use it, and it's just not a good fit for them, and they end up turning around and selling it for 12 grand and taking a 30%, 40% loss because it's not what they're going for. It's much easier to start with something small, buy a $300-400 used Chinese machine that's going to be problematic, that's going to teach you why you don't want certain aspects in your machine so you can understand what's going to work best for you, what you do and you don't like. If you buy a less expensive used machine, you pick up a used machine for 500 bucks, and after a month of using it, realizing that you need a lot bigger bed and that you need more power than drive belts can give you, then you can know that, okay, I can now know what I'm looking for as I start moving forward. I would say definitely go out and research. Ask a lot of questions. CNC for Beginners on Facebook is a great resource where you can hop on and ask and get 60, 70 questions to your answer, and everybody's going to tell you what their favorite is. Personally, my favorite is Legacy. I've done some research into Shop Saber, amazing machines. The thing about Legacy and Shop Saber, as well as some of the other high-end machines, is they are not, they're not that affordable. Now, once you actually figure the value of them, they are very affordable. Hey, Mighty Sawdust, appreciate you showing up. Don't worry about being late. I think I ran a whole minute with my audio off, so you missed a minute less than you think you did. But thanks for showing up. Now, as we're talking about different size machines, there's a lot of good mid-range desktop machines. And I see the used ones come up on Facebook and KSL and Craigslist all the time. And I started with a used machine, went up to another used machine, and then I went to the factory and bought a factory refurbished used machine. From there, I realized where I wanted, what I needed, and that I had done my proof of concept. And that is a huge one. Can you make things that you can sell with your CNC? It is possible, but can you? I'd like to think anybody with the tenacity can do it, but the amount of CNC machines I see up for sale where somebody's hasn't exactly made a successful business out of it as much as they needed to, makes me think that it's not for everyone. So get your feet wet in something that's not going to hurt you too badly if you end up not doing anything with it. I started out 3D printing with a $4,000 3D printer. After I sold about $150 worth of goods on it, it made it so, well, actually after all the add-ons it was $45. So I only really lost about $4,200 on it. I could have started out with a $300 3D printer, realized that, you know what, I'm going to have the same problems with a big expensive one, and then I would only been out 150 bucks. So get your feet wet with something you can handle, and I highly recommend used. Find that killer deal, but make sure it's running. And when I got my first one, I got package deal. I got the computer I needed to run it. I got the software I needed to run it. And then I downloaded a free software to design on. And so I was in it very little, turned up selling that for more than I paid for it 6 months later, after I had sold a few products. So get your feet wet. It's a great question. Unfortunately, there's not a one-size-fits-all answer. If there was, I would say go to Legacy Woodworking Machinery and just buy the biggest CNC that you can afford. You can't go wrong there. It's a solid machine, but is it what you need? Look for what you need. Size, strength. There's belts are the cheapest, but they've got the least strength. Ball screws and rack and pinion, there's a great debate on which way to drive, which is better. Rack and pinion has its advantages, ball screws have their advantages. And it's more about knowing that the manufacturer used the equipment right when they built it, because if you build a ball screw machine right, it's better than a rack and pinion machine wrong. If you build a rack and pinion machine right, it's better than a ball screw machine done wrong. If you do them both, well, they're about a wash based on what you're doing. Another thing you want to look at is, does this have a router, like just your average DeWalt 1.5 horse router or whatever horse router it comes with, or does it have a spindle? Spindles generally have a lot more customizability. You've got variable speeds there. With your routers, you can change the speed on the knob generally, but once you start your cut, you can't go in and change that. That makes them a lot cheaper. The other thing is spindles are a lot quieter. Routers are noisy and they don't have the durability. But that makes routers cheaper to start with, so you may go with a router for a little while and realize that you want to upgrade to a spindle. Good thing about that is a lot of times you can upgrade from router to spindle without changing your machine out. So there's a lot of different things there. One option I saw recently looking into it that I hadn't thought of, but it's a great option, is when you're getting started, if you're just wondering if you can sell CNC made products, try outsourcing your work. Find somebody locally that's got a CNC machine and say, hey, I'm doing these flags and I want to upgrade my flags with some 3D design. Can you do some CNC work on these for me? I'll pay you for the CNC work and I'll upcharge my clients, and then see if your clients are buying. Because the last thing you want to do is go spend $18,000 on a machine and then find out that your clients don't want to pay for the upgraded flag. So a lot of things to look at. As far as all the different machines out there, I mean, there's Bob's, CNC, x-carve, long mill, Shapeoko, Shop Saber, Legacy, CNC for newbies, Onefinity, and on and on and on. And everyone is right for someone. So figure out who you are. And if you want me to go further in depth with this, let me know in the comments, and I'll dig in deeper at another time. So thank you very much for that question. Let's keep driving on. I'm not seeing any questions in the chat right now, so let's see what our next question is from social media. So from woodworking YouTubers, again, in CNC for beginners, Jack, Donna, and Royce want to know which software to use. And this is a fun one, because guess what? It's the exact same answer as CNC. There's 1,000 choices and each choice is right for someone else. I personally like Aspire. It is a Vectric product. Vectric is a software company out of, I believe, the UK, and they design a great product. There's a lot of people using Vectric products, so there's a lot of support, there's a lot of how-to videos. Now, if you're getting a Shapeoko, I would definitely recommend Carbide Create, because that is actually a Carbide 3D who makes Shapeoko brand products, so it gives you the ability to have that manufacturer support with it. If you're starting out low budget, I started with Fusion 360, and they do have a free hobby version or a free trial version, and you can actually use it to do carvings. The wonderful thing about Fusion 360 is you can use it for 3D printing and CNC carving and designing a house or modeling a car or a spaceship. That means it is a very powerful tool, and you can get lost for days in trying to figure out how to do a simple v-carve. And when you're starting out with CNC, a simple v-carve or a profile toolpath is where you're going to want to start. So I would definitely recommend downloading the free trial version of whether it's Carbide or a Vectric product, their desktop, or any of these other products, and play around with it. You may not be able to carve with it, but you can see how user-friendly it is and see if it fits your needs. One of the great things I love about Vectric is they've got 4 or 5 different layers, starting with a really inexpensive desktop version. And if you go from the desktop version, upgrade that to a pro version, you only have to pay the difference. You get full trade-in value for what you paid. And then as you upgrade from your pro, you get everything you put into that so far towards your Aspire. And I believe the only difference between Aspire and Pro is in Pro, you can utilize 3D models. In Aspire, you can manipulate and build 3D models. So if you're not building 3D models, you don't need to go the whole $2,200 into that. So that's where I'm at with the software. Is you've got your base software. This is where you design. For my laser, I use Corel Draw. So it kind of depends on what you're doing. After you design it, you have to send it to your machine in G-code. And so you're going to have to turn that into G-code, and most softwares, design softwares, have a post-processor built into them now that you can actually use that to change it to G-code. Or GRBL, which is another, actually, does GRBL use G-code? Either way, you've got to send it to something that will send it to your machine. So there you're going to need either Mach 3 or GRBL or Delta or one of these controller softwares. And a lot of times these come with your machine from the factory. If you're buying a second-hand machine, make sure it's got the software necessary to drive it and that you only need the design software. Or better yet, find a piece of design software, or find one that's got a piece of design software included with it. I see software going on sale all the time. Somebody who either sold their machine and is trying to sell the software. The one thing you want to be careful of is avoid pirated software. While yeah, it's bad for the environment and everything else, it really ends up coming up with a lot of problems that you're not able to fix. Or you're not able to get the support you need. It's worth it to go to the manufacturer and get, or to the program company and get the legitimate software. And a lot of softwares like Xtract, you can actually transfer from the legal owner to you for a small fee. All right, so we covered that. Let's see where we're at next. Again, if you've got a question and you're in the live chat, feel free to throw in the chat. Just put a capital Q in front of your question and I'll know that that's a question and we'll tackle that one for you. Okay, where are we going next? Bits. There is a fun question. With CNC, there are a few bits out there. There are a few types of bits and a few different purposes of bits. And every single bit comes with a different purpose and a different set of capabilities. And to show you what I mean, let's take a look at a couple of the different bits out there. Okay, here I am in Xtract. This is my Aspire, and this is a profile of a couple of the different kinds of bits out there. Some of these are very simple, like if we look at the Amana tools, these are just spoil board clearing. It is a flat bit. And so that is something like this one right here, where it is just going to cut that surface and make it smooth for you. If we come down here at precise bits, we start seeing things like sharp V points. These are good for very tight details. And then we've got different depths or different degrees for different depths of cuts and different effects. Then we get into our tapered ball nose. Now, these are kind of precise. I love precise bits, and it's precisebits.com. I'll throw a link to that in the description below. They're one of my favorite bit manufacturers out there. So they make some really nice 3D carving tapered ball nose. Now, I do have a tapered ball nose here I'm going to show you, but it's actually the Legacy Woodworking or Awards cutters. So this right here, check out this beast. That is a 1/2 inch shank, 1/8 inch diameter tip, 3-degree tapered ball nose. That thing will cut some meat out of a blank. And with those, you can go a lot deeper than you would with a straight ball nose because of that taper. So that's great for your 3D carvings. Okay, getting into here, again, our surfacing bits. Bowl and tray, these are good for when you're cleaning out a tray. So this edge on this tray right here, I don't know if you're gonna be able to, there we go, right here, this rounded edge right there, I cut that with a bowl and tray bit. So that gave me the ability to hollow that out. And then I used a surface planing bit to carve out the center. Okay, 2 flute, your straight cutters. That's another thing you need to look at. When you start getting into straight cutters, you start looking at different flutes. You can get 2 flute cutters, 4 flute cutters, all different flutes and cutters. With wood, we'll talk about this when you get into feeds and speeds in a little while, but with wood, you need to be moving more chips, more large chips. With a 4 flute, you're cutting those chips in half, so you actually have to move your machine twice as fast to cut at the same RPM. Okay, we've got our 2 flute straight, V-bits. These are the basis of V-carving. So this is a 60-degree, this is a 90-degree, and basically as you cut, this is going to bring 2 45-degree angles coming up from the base. This will give you the effect of something like, wrong side. this sign over here where I've got that stacked text. Great for them. Okay, different bevels. Your core box. These are just rounded bits. That's going to give you a nice, it's like a tapered ball nose, only giant. It's going to give you a nice rounded bottom. Your ball noses, they're very close to your core box cutters, except generally they're designed more like a like a straight, except they're rounded here. I'm not sure if you're going to be able to see that on this, but there is a little bit of a rounded edge on that, and that's going to give you a rounded bottom. I don't use the ball nose very often. I'll use the core box if I need to hollow out a big area, and I'll use the tapered ball nose if I need to get a rounded surface on the bottom, or if I'm doing my 3D carving. So that's actually, those are one of my favorite bits, is that tapered ball nose. Then we get into our profile bits. So here we've got plunge roundovers. What this is going to do is, just like the V, it's going to give us that, except a straight line, it's going to give us a radius there. Flat roundovers, these are going to give a radius, flat bottom. And then plunge cut roundovers, rope pen, rope molding. What these are going to do is they come in to a point and then they give you a radius. So if you take a rope molding and spin that around, do a rope molding here and then a rope molding here, that's going to give you a twist that looks like a rope. Now this was done on a 4th axis, so this was rotating as the bit stayed vertical, or stayed in one place on this axis and just moved down this way, moved back and forth. So that's how we got that rope effect. Down here in the barley twists, these are great for if you're going to do, a barley twist is a lot like a rope, except it doesn't have a point at the bottom, and they're great for doing like hollow spirals. So I did the wave here with a barley twist, and then I used a straight cutter to come in here and get that straight cut there. That was a 1/2 inch 2-flute straight cutter that I cut that out with, and then a 2-inch barley twist that I used to cut there, and just did a 2-inch there and then another one there. I did 3 starts on this, so I did it cut starting here, then cut starting here, cut starting here. So bits come down to what you're using it for. Magnate has designed some very specific bits, like your classic spiral. These give you specific molding patterns, so you're able to create very intricate work without having to go through and 3D carve all of that. Then you've got your dovetails and your ball ends, and then your side grooves. These are like V cutters, except on the side. Great for cutting threads if you're doing a threaded insert, side reading, side fluting. So the reason I show you this is not to overwhelm you, but to say that when it comes to bits, the world is wide open. Magnate is fantastic. I use them for all of my large bits that are carbide tipped. I go for them because not only they give you a good quality bit, but the price, you can't beat them. If I'm going for a precise bit, like a bit that has precision abilities, anybody want to guess where I go for my precise bits? That's right, precise bits. This right here, I don't know if you're even going to be able to see that. That is a 0.021 inch diameter 2-flute cutter. That is for cutting shell, or I also use them for cutting mother of pearl. Did some great some great inlays for Rask. So yeah, yes, it did come from precise bits. So yeah, if it's the fine stuff, my tapered ball noses, I like to get those from precise bits. And so Magnate, they are a great source. You can go directly to them. When I'm doing a bulk purchase, 6, 7, or 10 bits, then I'll go to Magnate and I'll pay the shipping and get a little bit better price. If I'm buying 1 or 2 bits, I buy them from Magnate through Amazon. And so I don't have to pay the shipping. I just pay a little bit more for the bit. It balances out, but it saves me money on the individual purchase. So it does kind of put a wash there. So the Magnate links that I put in the description below, they are links to Magnate bits on Amazon. But if you want to go straight to magnate.net, they can help you out with just about any of these cutters. So great question. I do appreciate that one. Let's see what we've got next. Let's see. I think we covered bits pretty thoroughly. So, Brian, I believe this came across on CNC for Beginners. He asked about laser attachments. Laser attachments are they're kind of a gray area for me. I haven't used a laser attachment on my CNC. I have a standalone 45 watt CO2 laser. And the reason I have a standalone laser is because I want something that's going to give me the ability to really cut in or dig faster. And as we start looking at speeds, you're gonna see a huge difference between the different kinds of lasers. There's three primary kinds of lasers that we deal with. There's diode, CO2, and fiber lasers. Fiber lasers are your most expensive, engraving deep or cutting metal. They start at about $3,000 for a small one and can go, well, as much as you want to spend. I've seen them in the several hundreds of thousands of dollar range, but they're cutting sheet steel 1/2 an inch thick and just blowing my mind. We're not going to get that in our woodworking shop. We don't need it. CO2 lasers, on the other hand, they're going to give you a quick cut in. I've actually cut thicker than 1/4 inch material. I've cut 1/2 inch pine with my 45 watt CO2 laser. I can do a really quick raster, and I can cut even 1/4 inch MDF pretty quickly. If we're looking at diode lasers, this is the kind of laser you're going to mount on your CNC. A lot of them come retrofit, so you can actually adapt them to your Shapeoko or your different your x-carve. A lot of these machines can handle them. Make sure that it's compatible with your controller. Like I said, there's Mach 3, GRBL, and Delta. Delta, we're not compatible yet. I've been working with Legacy, and we're actually we're really close to getting compatibility, but we're not there yet. It's going to require an extra board go in to control that. And I've been working with a couple of different laser companies to help facilitate that. But as we start looking at this, you need to make sure what you're getting is compatible. The other thing you want to look at is power. A lot of lasers come in at 7.5 watts, and this is enough to cut 1/8 inch if you go slowly. Some will do 1/4 inch, but you're almost at a standstill. If you're doing just a light raster across the surface, it could still take a very long time. So find somebody who's got the laser you're looking at and ask them what speeds and feeds are going to be best for your machine. Another company that I've looked quite heavily at is Endurance Laser, and they've got a lot of things that are unique. George, he's their CEO, and hey, it looks like he just sent me a message. What do we got? That's probably a George bot. Looks like he's saying we've launched our Christmas sales. Don't miss them. So right there, hey, nobody does not like a sale, right? Some of the things I love about Endurance Lasers is not only does he have decent prices on them, I mean, we can get a 10 watt for $500, but he also has the ability, or has designed in the ability, to use his Duo system, 15 watts. This is multiple lasers, so one points straight down, one mirrors in and goes down and goes point with that. So now you've got multiple lasers on target, and this gives you more power, and more power means faster cutting. So I've seen a lot of their work, a lot of their videos, so I would definitely recommend looking into Endurance Lasers. The other one I'd look into would be probably JTech. The reason I'd look at JTech is they've got a lot of people out there who have them, and they've got a lot of compatibility. They really push the compatibility, and that's one thing that I would say is find somebody who has the laser you're looking at and ask them, hey, I'm looking at getting this JTech, I'm looking at getting this Endurance, and what are your thoughts? And they'll say, well, I like the JTech, but I got this size, you need to go the next size larger. Or I got the largest size and it doesn't quite do what I need. So lasers are a great add-on. My big caution with that is it is going to go a lot slower than you want it to. If you're already deep into 3D printing, you'll probably be okay with a laser, because the only thing slower than a laser is a 3D printer. All right, let's see. So we've tackled lasers. Let's look at Darius asked, can you cut on an angle? So this is kind of an interesting one, because as we're looking at the ability for a CNC to cut, typical home or hobby and lower end pro models are 3-axis CNC machines, which means they have the ability to go up and down, forward and back, side and side. The bit will always be perpendicular to the machine surface. So this would look at it and say, well, it's hard to cut on an angle without getting an articulated head to where you can actually make the entire head. Now you're talking CNC 6-axis robots that cost hundreds of thousands of dollars, or 6 figures. Let's go there. So, but the answer is yes, you can cut on an angle. The easiest way to cut on an angle is, well, let me show you. Is with a V-bit. Remember I showed you earlier, this V-bit, it 60 degrees cuts to 30-degree angles. And so what that's going to do is, as you drive that bit in the wood, it's going to come down here and it's going to cut a 30-degree angle right there and a 30-degree angle right there. So if we cut this all the way down, all the way across, that is going to have a 30-degree bevel on it. And so yes, you can cut. The easiest way to set up is just with a bit that's going to cut at the angle you need. Now, what if you can't get that exact angle? What if I need a 22.5-degree angle? Can I do that? Yes, you can. What we can do here is we can take our material and actually angle it. So make a little fixture or something. So here I've got this board elevated with another board, to where if I fix this in here, it would create an ever so slightly slope. This is a very inexpensive way to build this. And if it's something you're doing repetitively, you just build a fixture that holds it at that angle, and then you're able to do repetitive cuts at that angle. So one way to do it is with that. There are some who build a fixture off to the side of their machine. So with the fixture on your machine, you start running into Z clearance. So here we've got our representing our spindle or our router. You've only got so much distance between here and here, and if we slope that up from on top of the bed, right there, we're getting into probably our max Z height, which is something you don't want to get into. But if you build a fixture over here, now you can slope that up, and you can do any angle from straight up all the way to just about flat. If you build your fixture right, you could go flat, and that gives you the ability to cut. As you see my mouse pointer right there, that is a vertical angle, but after we move that off, we've got a 12, 13 degree slope. Or if we surface the top, we've got that same angle at a 90 from there. Now, there are options out there. Certain manufacturers, not to dime anyone out, Legacy, they build a vertical vise on the front of every